but space can travel faster than the speed of light. That's what's meant by warp drive.
The unveiling of a warp drive-equipped starship was unlike anything the aerospace community had ever seen. The world had been familiar with SpaceX pushing boundaries, but what Elon Musk revealed went far beyond incremental innovation. The event took place under the kind of quiet yet electric atmosphere that tends to precede history-defining moments. The starship itself, already an icon of deep space travel ambitions, now bore an entirely new heart, a propulsion system that appeared to break the long-standing shackles of conventional physics as understood by mainstream engineering. The very term warp drive had for decades belonged exclusively to the realms of science fiction, an idea loved by dreamers but treated with skepticism by the scientific establishment. Yet here it was, mounted to the belly of a sleek interstellar vessel, gleaming under presentation lights as if the line between imagination and reality had simply been erased. Before we start, please don't forget to like and subscribe to our channel for more updates. The presentation began with the familiar confidence Musk brought to his most daring announcements. He explained that the new propulsion concept was not merely a faster engine, it was a fundamentally different way of traversing space. Instead of relying on the brute force of chemical rockets, or even the high efficiency of ion propulsion, the warp drive system would create a localized distortion in the fabric of space-time itself. The starship would, in essence, manipulate the geometry of the universe to shorten the distance between 2 points. To those who understood the gravity of what that meant, the implication was staggering. This was not just about going to Mars in weeks rather than months, but about reaching the moons of distant gas giants in days, perhaps even visiting star systems that were previously beyond the reach of human lifetimes. The technical portion of the reveal was both mesmerizing and baffling. SpaceX engineers had somehow managed to construct a working drive system that created a controlled warp bubble around the ship, a concept that until now had remained purely theoretical in advanced physics circles. The mathematics had been there for decades in various speculative models, but no one had the material science, energy control, or practical application to make it real. Musk described how the warp field would contract space-time in front of the vessel and expand it behind, allowing the ship to surf across the distortion without breaking the cosmic speed limit in the traditional sense. For observers steeped in Einstein's theories, it was a mind-bending moment. Here was a machine that didn't violate relativity but cleverly sidestepped it. The starship itself had been redesigned to accommodate this unprecedented technology. Its hull had been reinforced with advanced alloys capable of withstanding the stresses of space-time manipulation, while the internal structure included a network of energy conduits feeding into the warp core. Musk highlighted that the core was not fueled in any conventional sense, but instead tapped into a controlled form of zero-point energy, extracting power from the quantum fluctuations of empty space itself. This concept, long ridiculed as impossible or impractical, had apparently been mastered in the pursuit of interstellar travel. The energy output of the system was said to dwarf anything produced by nuclear reactors or even antimatter concepts. Yet it operated with silent, almost eerie stability. The audience, composed of journalists, scientists, industry competitors, and a handful of government officials, struggled to absorb the scale of what they were witnessing. If the system worked as described, it rendered current rocketry methods obsolete overnight. Chemical propellants, ion thrusters, nuclear thermal rockets, all the incremental steps humanity had been taking toward faster spaceflight were suddenly relics of a slower era. The warp-capable starship stood as both a challenge and a disruption to the aerospace industry's very foundation. No longer would interplanetary or even interstellar travel be an endeavor measured in years or generations. It could now be approached in terms of weeks or months. The implications for exploration were immediate and profound. With warp drive technology, human beings could realistically travel beyond the confines of the solar system within their own lifetimes. The tantalizing possibility of visiting exoplanets, once a dream reserved for science fiction novels, was suddenly a topic of serious conversation. Planets orbiting in the habitable zones of nearby stars, such as Proxima Centauri b, could be reached in practical time frames, enabling direct study and perhaps even the beginnings of colonization efforts. The sheer expansion of the human frontier that this represented was difficult to fully process. The engineering community was especially captivated by Musk's brief but impactful description of how the warp drive maintained stability. Traditional propulsion systems involve managing forces, thrust, and fuel flow. A warp system required the active manipulation of space-time geometry, which demanded precision beyond anything human-built machines had ever attempted. Sensors and field projectors arranged throughout the starship's hull would work in real time to maintain the shape and intensity of the warp bubble. Even the smallest irregularity in field symmetry could have catastrophic consequences, so the control systems were governed by AI processors operating at quantum computational speeds. One of the most fascinating aspects of the announcement was the sheer confidence with which Musk presented the achievement. This was not a tentative proof of concept or a lab-scale experiment. The warp drive was integrated into a full-scale starship, tested in unmanned trials, and prepared for a near-future crew demonstration. The footage he displayed, showing the starship vanishing from one point in near-Earth space and reappearing at a location millions of kilometers away in what appeared to be a fraction of a second, drew gasps from the crowd. Even if one assumed there was some visual trickery, the data presented alongside the footage, timestamp telemetry, energy usage logs, and distant sensor confirmations, was overwhelming in its consistency. From an industry standpoint, the warp drive announcement landed like a meteor. Aerospace firms that had spent decades refining reusable rockets now faced a paradigm shift that rendered much of their development roadmaps irrelevant. Governments that had invested billions into conventional propulsion research were suddenly confronted with the possibility that private enterprise had leapfrogged them entirely. The commercial satellite industry, the space tourism sector, planetary mining operations, all would be forced to reevaluate their strategies in light of near instantaneous interplanetary travel becoming feasible. The philosophical implications were equally staggering. Humanity's relationship with the cosmos had always been constrained by the tyranny of distance. The stars had been remote, unreachable lights in the sky, their distances measured in terms that dwarfed human history. The warp drive shattered that barrier. For the first time, the dream of a truly spacefaring civilization no longer seemed like a distant ambition, but a practical, near-term goal. The psychological shift alone, knowing that humans could leave the solar system and return within the span of a single career, had the potential to transform culture, politics, and identity. Musk's explanation of how SpaceX had achieved this breakthrough hinted at a fusion of multiple bleeding-edge technologies. Advances in superconductors, quantum computing, high-energy field containment, and even exotic matter generation had all converged in a way that made the warp drive possible. He described a decade-long parallel research effort, separate from the publicly visible work on reusable launch vehicles, that had quietly pushed forward on these fronts. The secrecy had been intentional, not for competitive advantage alone, but to ensure the science was mature enough before making such a world-altering announcement. The event also offered a glimpse into the future design philosophy of Starship variants equipped with warp drives. The interior layouts were optimized for longer duration voyages, even though the warp system reduced travel times dramatically. This was due to the need for redundancy and preparedness. Crews might still spend weeks in transit between certain destinations, depending on warp bubble efficiency, course corrections, and the gravitational complexities of target systems. Living quarters were more spacious, laboratories were integrated into the main decks, and radiation shielding was enhanced for journeys outside the protective bubble of the solar system's magnetic fields. One particularly intriguing element Musk touched upon was the potential for warp-capable starships to serve as mobile hubs of human civilization in deep space. With the ability to reposition across vast distances quickly, such ships could act as both exploration vessels and mobile colonies, bridging humanity's expansion into multiple star systems. This concept blurred the line between spacecraft and self-sustaining habitats, opening possibilities for a nomadic form of civilization untethered to any single world. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on Elon Musk revealing Warp Drive Starship and its industry impact? We want to hear from you. Thank you for watching and see you next time.